Okay, so kita sambung 1.3 electric potential. Okay, so before this, okay, we have learned in 1.2 about the electrostatic force. 1.1 electrostatic force, 1.2 electric field. Okay, so just a little bit of recap. Untuk 1.2, so 1.2 we learn about electric field, right? Dan kita gunakan equation F divided by Q naught. Atau another equation that we can use is electric field is equal to K Q divided by R square. Okay, so dekat sini, I just want to emphasize that Q besar dekat sini dengan Q kecil adalah dua benda yang berbeza. So this one kita panggil dia sebagai point charge. And then yang this one we call it as test charge. Okay, so apa beza test charge and point charge? Okay, so point charge is the charge that produce electric field. So let's say if we have positive charge, so kita tahu the region around it, we call it as electric field. Then the direction of electric field is going outward for positive charge. Okay, so this is what we call as point charge. So test charge is basically a charge that we place into the electric field. So we place a charge, this is Q kecil, that we place into the electric field ataupun maksudnya kita imagine saja ada another charge. So we call it as imaginary charge. Okay, so these two kamu kena pandai bezakan apa kegunaan dia. So the concept here we are going to use the same concept in 1.3 dekat dalam electric potential juga. Okay, so electric potential. Okay, let's go through the definition first, which is the first learning outcome. So electric potential is defined as the work done in bringing positive test charge from infinity to that point in the electric field per unit test charge. So the keyword here, okay, although I have already highlighted the keyword, so keyword yang paling penting adalah work done per unit test charge, di mana electric potential, the symbol is V, so work done here divided by test charge. So this is the test charge Q naught. Okay, ataupun kita boleh expand lagi this equation into this equation. Okay, so basically V is equal to work done, right, divided by Q naught. So work done we have learned in semester 1. What is the formula for work done? Ada yang ingat lagi? Apa formula untuk work done?
Fs.
Apa dia?
Fs cos theta.
Fs cos theta. Okay, thank you. Siapa tadi? Syafiq. Okay, so basically dia adalah F dot S, right? Divided by Q naught. So F di sini adalah force and S is the displacement. Okay, and then kita masukkan what is the formula for F that we learned in 1.1, which is KQ divided by R square. And then that pula dengan S di sini divided by Q naught. So this one, the formula is this one. Yang kita belajar dekat dalam 1.1, the electrostatic force, and S dekat sini adalah displacement. So in terms of this one, kita tidak gunakan S. Displacement distance kan kita tidak gunakan S. So we use the symbol R, which is the distance lah. This is the distance from the charge. So from here, we can cancel this one and this one, cancel this one and this one, and then barulah kita dapat KQ divided by R, which is, this is the formula. So we can either use this formula or this formula depending on the information that we have. Okay, potential ni, konsep dia sama macam potential difference, the voltage. Okay, di mana voltage adalah skala kuantiti. So, skala kuantiti bermaksud kita kena include the sign. So, kalau kita punya Q tu adalah negatif kan, kalau positif tidak masalah. So, kalau negatif, we always include the negative sign whenever we want to calculate the potential. Okay, tidak kisahlah dekat sini the work done, if the work done is negative, so you include the negative one. And then if the charge is negative, you include the negative one to find the potential. So the potential, the unit is volt, since dia adalah potential, sama konsep macam potential difference. So unit dia adalah volt, ataupun since work done is joule and then charge is coulomb, so joule per coulomb. So either one of these unit we can use sebab kedua-duanya adalah SI unit. Okay, so basically, okay, apa yang kita mau cakap dekat sini, potential ni adalah the work done. Work done, we learned this before in semester 1, work done is energy, right? So it is energy required to bring a charge from infinity to 1 point. Okay, let's say I have positive charge here. And then we have the direction, right? Okay, so we have another charge, test charge, another positive charge. So this positive charge is at infinity. And then we want to bring this positive charge into the electric field. So we want to bring it into this point here, point A. So when we bring this one to here, obviously we require energy. So when we require energy, work has been done. So there's a work done at a certain value to bring this charge into point A. So since work is joule and potential is volt, okay, we want to make sure dia punya unit ni tally. That's why in order to tallykan dia punya unit ni, kita bahagi So kita bahagi work dengan charge. Charge yang apa? Charge yang kita gunakan daripada infinity ni dan masukkan ke dalam electric field. Okay, so maksudnya kita mau cakap dekat sini, potential, work done is the energy required to bring the charge from one point to another point. So one point dekat sini, based on the definition, it is point at infinity. Okay, so let's say lah, if we want to find what is the potential at this point, dia minta potential dekat point A saja. So in order to find this potential at point A, kita gunakan this formula here, this one, di mana K adalah the constant, Q here is the Q from this point charge. So this is the Q. And then divided by the distance. Distance daripada mana? Distance daripada charge ke point A. So this is the value for R. Okay, as simple as that, you just use this formula. Any questions so far?
So far yan. Dah habis.
Clear,
So far
Miss.
tidak.
So far, okay,
So far,
Miss.
okay. Okay. So meaning that here, there is only two formula that we are going to use in order to find potential, electric potential. So either this one or this one, depending on the information that we have. And you need to always include the negative sign in order to find the potential. So before this, to find the electric field, so electric field dan force, disebabkan dia adalah vector quantity, so we don't need to include the sign, right? Untuk cari E dan F. Electric field and force tidak perlu include sign. Sebab in the end kita akan tentukan direction based on our diagram. Siapa ni? Maizan, tolong turn off your mic. So, untuk skala quantity, we always include the negative sign. Okay, so this one is under the first learning outcome. Kita tengok the second learning outcome. Okay, so second learning outcome here is define and explain equipotential lines and surfaces of an isolated charges in a uniform electric field. So the term here is equipotential. So apa maksud equipotential di sini? Meaning that it is equal in potential. So apa maksud equal in potential? Okay. Semua yang letak dekat sini ada dalam nota kamu. So this one here and this one memang ada dalam nota kamu. Okay, so equal in potential meaning that, okay, we know that, okay, apabila kita ada satu single charge, okay, dia akan ada direction of the electric field. So the dash line here, represent the region of the electric field. Okay, let's say if you want to find what is the potential at point A and what is the potential at point B. Okay, as you can see here, A dengan B, point A dengan B adalah on the same line. So it is on the same line. So bermaksud di sini, the potential untuk A dan B adalah sama. So equal in potential. So mana-mana point yang duduk dekat line yang sama, dash line yang sama, potential dia adalah sama. So setiap line ni, circle line ni, represent value for potential. So meaning that here, dekat point C, potential dia berbeza dengan dekat point B. Okay, so that is what we mean by equipotential line and surfaces. So either line ataupun surface lah kita panggil di sini. Okay, so from here, daripada kita punya formula tadi kan, V is equal to KQ divided by R. So here you can see that when the distance is smaller, the potential is higher. So as you can see here, the potential dekat point yang dekat dengan charge lebih tinggi berbanding the potential yang lebih jauh daripada the charge. So sama juga untuk uniform electric field. So uniform electric field ni kita boleh dapat daripada mana? Daripada mana kita dapat uniform electric field? Macam mana terhasilnya uniform electric field? Anyone?
Parallel metal bar.
Okay, yes.
Opposite charge.
Okay, so kita akan dapatkan daripada parallel metal plates of opposite charge. So apabila kita ada plates yang parallel to each other, okay, so contoh dekat sini this one positive, this one negative. So kita akan dapatkan satu electric field yang uniform. Okay, dia akan uniform maksudnya the space here is uniform compared to here. Okay, compared to single charge. So kamu nampakkan dekat sini, space dekat sini dua ni sangat kecil berbanding space dekat sini. So dia punya electric field tu tidak uniform berbanding dengan dekat dalam plates. Okay, so here sama juga. If we want to compare the potential at point A and point C, as you can see, the distance here is larger untuk point C. So potential untuk point C lebih rendah berbanding potential untuk point A. So depends pada soalan lah, adakah dia in relative to positive plate or negative plate. So this one actually uniform electric field ni kita akan tengok dekat 1.4 nanti. So basically kesimpulannya dekat sini, I just want to emphasize that point dekat line yang sama akan ada potential yang sama. Okay, so if we want to find the difference in the potential, let's say I want to find what is the difference between this potential at B and potential at C. Obviously there will be difference. So we call this as potential difference ataupun kita gunakan delta V. Delta meaning that there's a change in the potential in the value. Which, okay, kita masuk ke learning outcome yang seterusnya, masih juga potential, but this one we call it, we want to calculate potential difference between 2 points. So, let's say lah, macam ni, we want to bring the charge, okay, the charge from point B, daripada point B ni ada charge, kita pindah kepada point C. So there's a difference in potential here. So how do we calculate the difference in potential? Kita gunakan delta V. It will be V final, potential final minus potential initial. So final position kita adalah C sebab kita bawa daripada point B ke C. So bermaksud di sini VC minus VB. Okay, simple saja. Kamu just tolak final tolak initial. Okay, any question so far? Tidak. Okay, so macam yang Miss cakap tadi, dekat line yang sama, potential adalah
So far
kosong.
tiada, Miss.
Okay, dekat line yang sama, potential adalah kosong. So, kita boleh buktikan dekat sini, if we want to move the charge from point A to point B, okay, point A, maksudnya delta V kan, maksudnya point A to point B, VB minus VA. Since, this is the formula, right? Okay, since the Q here is, the K is the constant, right? Q adalah sama sebab kita akan in relative to what is the value for Q here. Apa Q dekat sini. And then distance pun akan sama because the distance is from here to the line here. That's why the potential is different. Maksudnya there is no work done. Okay, tiada kerja yang dilakukan untuk pindahkan charge daripada point A ke point B. Okay, so that one is for potential difference. Okay, kalau semua boleh faham sudah, kita terus masuk example lah untuk kamu lebih faham. Okay, kita masuk example. Okay, example 15 here. So we are given 2 point charges, okay? The keyword here is point charges. Q1 negative 40 microcoulomb, Q2 negative 30 microcoulomb are separated by a distance of 15 centimeter as shown in the figure here. So kita ada Q1 negative, Q2 pun negative, and they are separated by distance of 15 centimeter. Now what we want to find is what is the electric potential at point A. Oops, at point A. So point A dekat sini adalah 5 cm daripada Q1 dan 10 cm daripada Q2. Okay, sekarang kita ada dua charge. Tadi in order to find potential due to one charge only, kita terus gunakan the formula V is equal to KQ divided by R, right? Tapi sekarang ni kita ada dua charge. Maksudnya dekat point A ni, dia akan rasakan potential daripada charge 1 dan juga charge 2. So this one, it's simple as well. So because we want to find what is VA, then VA since ada Q1 dan Q2, kita tambah sajalah V1A. Okay, potential at A due to charge 1, potential at A due to charge 2, plus V2A. So, kamu boleh kira satu-satu ataupun terus masukkan dalam equation ni. Maksudnya dekat sini, K Q1 divided by R1A. Distance di sini adalah distance point A kepada charge 1. Dan dekat sini adalah distance point A, sorry bukan B. Point A kepada charge yang kedua. and then you just masukkan the value. So value here Q1 is negative, so masukkan negative divided by the distance is 5 cm, so convert to meter, 0.05 tambah Q2 adalah negative 30 and then divided by the distance between Q2 and A is 10 cm, so convert to meter. Dan kamu akan dapat VA is equal to
negative 9.9 exponent 6.
negative apa?
9.9.
Sorry, Miss nak dengar. Can you say it again, Jason?
Negative 9.9
9.9
exponent 6.
exponent 6 volt. Okay, thank you, Jason. Semua dapat value yang sama, negative 9.9 exponent 6 volt.
Dapat, Miss.
Dapat.
Dapat, Miss.
Okay, boleh Miss proceed? Adakah cepat sangat?
Boleh.
Boleh, Miss.
Boleh. Okay, so the next question, question B. We want to find what is the electric potential at point B. So dia bagi dekat sini point B dekat atas. 13 cm from Q2 and there is a certain distance. Okay, so kalau kita dibagi gambar ajar macam ni kan. So distance dia adalah kita gunakan macam ni. Kita akan gunakan triangle. So there is a distance here. Which is what is the distance? We need to calculate. So the distance here would be using the Pythagoras theorem. 13 square plus 15 square. Dapat berapa?
Nineteen
19.8 centimeter. Okay, so there's a distance 19.8 centimeter. Okay, now we want to find what is the electric potential at point B. So gunakan cara yang sama, but now kita punya distance akan berubah. Okay, so soalan B, VB, V1B plus V2B. So kita masukkan K Q1 divided by R1B plus K Q2 divided by R2B. Dan masukkan 9 exponent 9. Q1 adalah negatif. Negatif berapa? Negatif 40 exponent negative 6 divided by the distance. So distance Q1 kepada B, this one yang kita sudah kira tadi, 19.8 cm. Convert to meter. Then plus negative 30 exponent negative 6 divided by the distance B to Q2, which is 13 centimeter. And then kamu akan dapat
Negative 3.89 exponent 6.
negative 3.990.
3 point.
Betul kah? Negative 3.9 exponent 6. Is it? Betul?
Yeah. 3.89. Yeah, sama tu.
Alright. Thank you, Jason. Semua dapat value yang sama.
Dapat Miss.
Dapat.
Dapat Miss.
Okay. Ada soalan? Tiada soalan, semua boleh dapatkan. Okay, so tiada soalan, boleh Miss proceed to the next example?
Boleh Miss.
Boleh.
Boleh Miss.
Okay, kita proceed to the next example, example 16. Okay, so example 16 di sini, we are given 4-point charges. Okay, ada 4 charge di sini. They are located at the corners of the square. So we have square here, and at the corners, each of the corners, we have point charges. And then given that the charge is represented by unknown, Q, 2Q, 2Q, negative 3Q. But we are given that the value for the Q, which is 4.8 microcoulomb. Okay, now what we want is find the electric potential at the center of the square. So we want to find what is the electric potential at the center of the square here. Since dia adalah square, maksudnya each of this side has the same value of 8 centimeter. So this one adalah 8 centimeter, this one adalah 8 centimeter, this one is also 8 centimeter. Okay, now we want to find what is the potential at this point. Okay, kita letaklah point O. So kita ada this one. Okay, we want to find what is the potential at point O. Okay, so sama juga macam method yang tadi. Cuma tadi kita ada dua point charge, right? Now kita ada 4. So meaning that in order to find V at center, VO. Okay, before that let's label this one. Kita label dahulu this one Q1, Q2, Q3, Q4. Maksudnya we want to find V1 O plus V2O plus V3O plus V4O. Maksudnya what is the potential due to this charge, due to this charge, and this charge. Lepas tu barulah kita tambahkan semuanya. Okay, so now, okay, keluarkan formula dahulu. We have K over R. Okay, since dia adalah distance daripada sini ke sini akan sama because it's the square, right? So this one akan sama. Yang berbeza adalah Q1, Q2, Q3, Q4. So kita boleh factorizekan, dapat Q1 plus Q2 plus Q3 plus Q4. Boleh follow? Siapa yang blur?
Boleh Miss.
Boleh Miss.
Boleh lagi kan?
Boleh Miss.
Soalan masih senang lagi ni. Okay. So now we have the value for each of the charge, but we don't have the distance. So distance dekat sini mestilah distance daripada point tengah ke charge yang seterusnya. So how do we find the distance here? Macam mana cari distance?
Theorem.
Boleh someone kirakan untuk Miss? What is the distance?
5.66.
Oh, cepatnya. Siapa yang kira tu? Azmi? Berapa? 5.66
66.
cm. So kita gunakan teorem Pythagoras sahaja. Okay? So we can either use like this one. Macam ni. 5.66 tu adalah each of this kah?
Ya,
Ya.
pada
Kan? So kamu akan
Aku
gunakan this triangle di mana kamu akan dapat, so this one 8, sini 8, so dekat sini kamu akan dapat 8 square plus 8 square, dapat berapa? Dapat something and then bahagi dengan 2. Macam tu Azmi buat.
Ya.
Okay, so dekat sini kamu akan dapat 5.66 each of this. So distance untuk semua ni akan sama lah. And then lepas tu masukkan sahaja 9 exponent 9 divided by the distance 5.66, convert to meter, and then barulah masukkan the value here. So value Q1 tadi adalah Q, Q2 adalah 2Q, Q3 negative 3Q, dan Q4 2Q. Dan kamu akan dapat negative 3. So here you will get 2Q, right? Is it? 4, 5, okay. So 2Q, and then barulah kita substitute the value for Q, which is given here, 4.8 exponent negative 6. So 9 exponent 9 divided by 5.66 exponent negative 2. 2Q, apa tadi? 4.8 exponent negative 6. And then kamu akan dapat
1.5 or 3 exponent 53 exponent 6.
exponent 6 volt. Positive or negative? Positive, right? Okay, positive.
Yeah, positive.
1.53 exponent 6 volt. Okay, so jawapan dekat sini, actually this is the exact jawapan lah kalau kita tidak eksponenkan dia. Kamu akan dapat 1529203.5. So soalan jawapan ni salah. Ataupun kamu boleh terus juga leave it the answer like this, 1.53 exponent 6 volt pun diterima juga. Okay, any questions so far?
Tiada.
Okay, Teda, can I proceed to the next example?
Boleh, Miss.
Boleh.
Boleh, Miss.
Orang yang sama aja jawab. Jason, Amin, Syahira. Yang lain mana? Yang lain mendengar juga ni?
Dengar, Miss.
Okay.
Dengar, Miss.
Benar, Miss.
Alright, so kita proceed the next example. Example 17. Okay, so example 17. Okay, we are given here 2 points, point S and T. They are located around a point charge, dan satu point charge positive 5.4 nanocoulomb. Okay, first question, what is the electric potential difference between point S and T? So we want to find what is the potential difference. So remember, potential difference kita gunakan delta V. Sebab dia ada difference, dia bukan potential sahaja. Potential difference between point S and T. Okay, so tadi Miss bagi tahu what is the formula for potential difference? Formula dia?
V.
E.
Final.
Okay, V final minus V initial, right? Okay, so in this case, which one is final, which one is initial? Mana satu final, mana satu initial? Anyone know? Ivy? Ivy ada? Ivy Azlinda. Ivy, are you there? Oh, Ivy ni di buai mimpi. Vivian? Vivian, are you there? Semua orang tiada ni. Miss cakap dengan siapa ni?
S.
Initial
Miss,
6.
banyak tak bagus lah.
Initial,
Initial S.
6.
initial S. This one initial. This one final.
Iya.
Macam mana kamu
Ya,
tahu mana
Miss.
satu initial, mana satu final?
Isya bercakap di distance jauh.
Sebab distance dia jauh. Okay. Tidak semestinya ya.
Salah.
So kalau, but thank you for your answer. Okay, kalau dia tidak bagi macam ni kan, dia tidak bagi tahu from point, which point to which point. So dekat sini dia sudah tulis between point S and T. So kita ambil je. Kita ambil je terus VST. So maksudnya yang final adalah S, yang initial adalah T. So VS minus VT. Kalau soalan tu dia tidak bagi tahu which one is initial, which one is final. So you just take straight away from here. The first point that that mentioned is S, so that will be the final. This will be the initial. Maksudnya kita terus tulis VST. So VST ni maksudnya this is the final, this is the initial. Okay? And then barulah masukkan the formula, and then KQ divided by RS minus KQ divided by RT. And then masukkan 9 exponent 9. And then the Q here, we only have one Q, positive 5.4 nano coulomb. Nano is which exponent berapa?
Negative 6.
Negative 9.
Negative 6, 9, right? Negative 9. Divided by the distance. So distance S ke charge adalah 6 cm. And then minus 5.4 exponent negative 9 divided by the distance daripada T ke charge. So from here to here, what is the distance here? 8, 6, 8, this should be 10, right? So the distance from here to here would be 10 cm. 0.1, betul ke tu?
Betul, Miss.
Okay. And then you will get
324.
354. 50,
24.
24. 324, thank you. Okay, semua dapat 324 volt.
Dapat ni.
Okay. Alright, next one.
Miss.
The next one, yes.
Kalau initial sama final tu terbalik salah ke Miss?
Nanti kamu akan dapat negatif lah kan?
Iya. Negatif.
So dia salah. Should be positive. Sebab tu kena make sure betul-betul mana satu final, mana satu initial.
Okay.
Tapi Miss, kalau kita letak modulus sebabkan potential difference,
Letak modulus.
sebab beza mustahil jadi negatif kan?
Let me ask another lecturer first, nanti Miss double confirm semula. But should be sebab kita, this is the same concept as potential difference yang kita akan belajar dekat chapter 3 nanti. It should be you need to include the negative one. But I'll double check and then bagi tahu nantilah. Okay?
Okay, Miss.
Yes, Vivian, you have any question? Vivian angkat tangan dulu. Okay, kalau tiada, let me proceed to the next question, question B. Okay, so question B here, calculate the work done in bringing a charge of negative 1.5 nanocoulomb from point T to point S. Okay, so now kita imagine there's another charge of a negative 1.5 nanocoulomb dekat point T. So there's another charge here at point T. Charge dia negative 1.5 nanocoulomb. And then we want to bring this charge from point T to point S. And what is the work done? How can we find this work done? Guna formula yang mana? Is it Fs cos theta?
V equals to work done over Q naught.
V equal to work done over Q naught. Okay. So since soalan minta tu the work done in bringing from point T to point S from here to here, and we already calculated the difference, the potential difference here, delta V, which is kita sudah kira dekat sini kan. Dan di sini pun initial dia adalah T, final dia adalah S. So it's the same value lah yang kita kira dekat soalan A. So we can use this one to find the value for work done. So here V will be 324 equal to work done divided by Q naught. So Q naught is given this one. Q yang kita dibagi adalah the test charge, negative 1.5 nanocoulomb. Negative 1.5 nanocoulomb. So work done di sini adalah sama dengan
4.86 exponent 7.
berapa? 2 point? 2 ke 4? 4 point?
Negative
4.86 exponent negative 7 joule. You should get negative, right? Okay, you should get
Yes,
negative
ma'am.
here. Okay. So tadi ada yang tanya tu kan, kalau lah kita dapat negatif ya, sebab kita balikkan negatif dekat sini and then kita masukkan dekat sini juga adalah negatif. And then nanti kamu akan dapat work done kamu adalah positif. So sebenarnya salah lah, sebab work done we need to know whether it is positive and negative. So before this kita belajar kan apa maksud positif dan negatif sign di sini untuk work done. Ingat lagi semester 1 apa maksud positif dan negatif?
By the system.
Apa dia Aiman? Dah dengar lah Aiman.
Done by the system. Gitu.
Work done by the system ataupun on the system. Maksudnya energy, adakah energy bertambah ataupun berkurang. So kalau negatif, the energy is reduced. So kalau positive, energy is added into the system. That's why the negative value here is very important. Although the work done is not a vector quantity, it's a scalar quantity actually. So the negative here just to indicate the reduction or the reduction or the addition of the energy. Okay? Ada soalan lain? Semua boleh?
Ada Miss.
Tiada, Miss.
Dah.
Boleh, Miss.
Boleh proceed. Example yang seterusnya. This one example berapa?
Boleh, Miss.
Example 17. So Miss proceed example 18. 18, do I need to do example 18? Okay, example 18. Okay, 18 dengan 19 sama. So kita buat example 18 saja. Okay, so example 18. So given here a test charge Q0, positive 2.3 microcoulomb is placed 20 centimeter from a point charge Q. A work done of negative 25 joule is required in bringing the test charge Q0 to a distance 15 cm from the charge. Okay, so benda macam ni kita kena lukis, tidak boleh imagine saja. So kita lukis dahulu. We have a charge here. So a charge Q, and then we have also the test charge. So test charge is placed 20 centimeter. So ni adalah test charge, positive, right? Q0. It is placed 20 centimeter from a point charge Q. So the distance here is 20 centimeter. A work done of negative 25 joule is required in bringing the test charge to a distance 15 centimeter from the charge Q. So test charge ni kita mau bawa dia ke satu point, di mana point tu adalah 15 centimeter daripada charge Q. So let's say lah that point is here. Kita letaklah dia adalah point A. So in order to bring from here to here, the work done is negative 25 joule. Okay, now determine the potential difference between point 15 centimeter and 20 centimeter from the point charge Q. Okay, so we want to determine what is the potential difference between point 15 cm di mana point ni dan point ni. Maksudnya, what is the potential difference here? Okay, so let's label this one point B. So we want to find what is the potential difference between these 2 points. Okay, so which one is initial, which one is final here?
B is initial, A is final.
So this one, B is initial, A is final. Okay. So we can find delta V is equal to VA minus VB. Or since we are given the work done, okay, kita sudah dibagi work done kan? So we can also use delta V is equal to work done divided by the point charge, the test charge. So work done here is negative 25. The test charge, what is the value for test charge here? This one, positive 2.3. Positive 2.3 microcoulomb. So the potential difference here would be, betul kah? Berapa negatif 25? Okay, what is the potential difference?
Negative 1.087 exponent 7.
1.087 exponent 7 volt. Okay, thank you Azmi. Yang lain dapat jawapan yang sama?
Dapat, Miss.
Dapat, Miss. Dapat, Miss.
Okay. Okay, so next one. Okay, we want to find what is the value of charge Q. Okay, so charge Q di sini dia tidak bagi kan tadi, dia just beritahu there's a point charge Q. But it's not given the value of the Q. So now we want to find what is the charge Q. So how do we find this charge Q? Anyone has any idea? How do we find charge Q? Siapa ada idea?
Use the potential difference.
Gunakan potential difference. Okay, so since kita sudah dapatkan potential difference here, then in order to get this potential difference, we get it from this formula. But now, kita boleh gunakan formula ni to find the value for Q. So, this formula actually, VA minus VB, right? Kalau kita expand dia, dia akan dapat KQ divided by RA minus KQ divided by RB. So this is what we want. This value for Q is what we want. So masukkanlah the delta V is negative 1.0 at 7 exponent 7 equal to K. K is the constant, and then Q is what we want divided by the distance. So distance daripada A kepada charge, point A kepada charge adalah 15 cm, 0.15, then minus Q divided by RB. So distance daripada Q ke point B, which is 20 cm. It's 20 cm. So kamu boleh dapatkan what is the value for Q.
(7.27 exponent negative 4).
7.27 exponent negative 4 coulomb. Positive or negative? Positive,
Negative.
right? Sama kah? Okay. 7.27 exponent negative 4 coulomb. Okay, next one. Okay, last question here. Determine the magnitude of the electric field strength at a point 10 centimeter from the charge Q. Okay, so there is one point here. Let's say this is point C. That is 10 centimeter from charge Q. So we want to find what is the value for E here, electric field. And dia minta magnitude sahaja. So kalau magnitude, we don't need to lukis lah, tidak perlu lukis the direction. So you just calculate using the formula. What is the formula for electric field again? E is equal to formula electric field? Anyone?
E equals to
KQ over
KQ
R.
over R square.
KQ over R square. Okay, thank you. So this one just masukkanlah macam biasa. You just masuk the value of K, and then Q is what we find just now. This one, 7.27. That is the value for the Q. Then divided by the distance. So distance adalah distance daripada point C ke point Q, which is 10 cm. And then kita letakkan square. So the E here will be
(6.543 exponent 8).
6.543 exponent
8.
8. And what is the unit?
Newton per coulomb.
Newton per coulomb.
Okay, Newton per coulomb. Okay, semua dapat?
Dapat,
Dapat,
Miss.
Miss.
Okay.
Dapat, Miss.
Okay, kalau dapat ada soalan?
Tiada, Miss.
Tiada.
Tiada, Miss.
Tiada, Miss.
Kalau tiada soalan, kita boleh proceed next learning outcome. Okay, untuk example 19 ni sama je sebenarnya untuk dengan example 18. Exactly the same, dia just tukar number je and dia tukar dia punya sikit lah. So this one kamu boleh buat sendiri nanti, example 19. Okay, so kita masuk the next learning outcome for this subtopic. Okay, so tadi we learned about potential. Okay, now we want to learn about potential energy. Okay, tadi potential saja, sekarang ni energy. Okay, so potential energy kita gunakan simbol U. Okay, macam samalah macam yang kita belajar sebelum ni kan dekat semester 1. We use the symbol U. Okay, now whenever there is a word change in, there is a change, kita akan gunakan delta. So now we want to find what is the change in potential energy. So there's a delta U here. So obviously when we're talking about the change, it is a change between 2 points in electric field. Okay, ada 2 point. Contoh macam tadi lah. If we want to move the charge from point A to point B, there is a change. There is a change in potential difference. There is a change in potential. There is also a change in potential energy. Okay, ada 2 benda yang berubah. Potential dan potential energy. Okay. So this one senang saja. Okay, since we learned before that work is energy. Energy is work. So potential energy is equal to work done. The work done. So since work done kita boleh dapat daripada formula V is equal to W divided by Q naught. So this one kita substitute dengan delta U. So kita boleh dapatkan this formula to find the potential energy. So delta U is equal to Q naught times with delta V. Okay, delta V is the potential. So here the change in potential. This one is the change in potential energy, and then this is the test charge. So gunakan formula ini sahaja to find the change in potential energy. Okay, since dalam soalan usually akan bagi 2 ataupun lebih daripada 2 charge. Okay, tapi dalam kamu punya syllabus maksimum adalah 3 charge sahaja. So apabila ada 3 charge, the potential energy for the whole system, we need to calculate the total potential for the whole system. So in order to calculate the potential energy for the whole system, dekat sini kita ada 3 charge, Q1, Q2, Q3, and we want to find what is the total potential energy. So this one senang saja kamu, because kita ada 3 charge kan, so kita couplekan setiap charge ni. So Q1 dengan Q2, Q1 dengan Q2, and then Q1 dengan Q3, and then Q2 dengan Q3. And then divided by the distance between that charge. So let's say if we couplekan Q1 dengan Q2 kan, so dibahagi dengan distance between Q1 and Q2. Sama juga macam tu lah. It's very simple, this formula untuk potential energy. Okay, so potential energy samalah. Kalau dia minta total potential energy is the same thing as total work done. Okay, 2 formula untuk potential energy. Satu total, satu lagi adalah the change in potential energy. So kalau dia minta 2, dia bagi 2 saja point charge, ada 2 saja, so dia ada charge yang ketiga, so this one buang lah. So this is the formula. Okay, it's very easy, very simple formula. Okay, so kita boleh terus masuk example. Okay, example 20, no. Okay, kita masuk example 22. So example 20 ni adalah soalan tutorial number 6. So this one nanti kamu boleh buat. Kita masuk example 22. Wait. Okay. So example 22. So we are given here 2 point charges, Q1 positive, Q2 negative. They are placed 4 meter from point P, 5 meter from point P. Okay, first question, calculate the electric potential at P due to the charges. Okay, so soalan macam ni dia selalu akan gabung potential dan potential energy lah. Soalnya soalan memang akan gabung sekali. So first thing you need to do is to find what is the potential at point P. So this one method yang sama macam yang tadi. So in order to find VP, we find V1P plus V2P. So masukkan K, the constant value, and then Q1 adalah positive 2 microcoulomb divided by the distance between P and Q1 4 meter plus Q2 is negative 6 exponent negative 6. Are you guys still with me?
Yes, Miss.
Yes,
Okay.
Miss.
Yeah, Miss.
Okay, just to make sure.
Yes, Miss.
Okay, and then Q2 divided by the distance from P to Q2, which is 5 meter. Lepas tu masukkan, and then you will get the potential at point P adalah sama dengan
Negative 6300.
6300 volt. Okay, semua dapat negative 6300 volt.
Dapat, Miss.
Okay. Next question. If a charge Q3, which is equal to positive 3 microcoulomb, moves from infinity to point P, determine the change in electric potential energy for this charge. Okay. So we have another charge Q3. Contohlah Q3 tu di sini ya. Dia positif kan. So Q3 ni dia adalah daripada infinity. And we want to move from infinity to point P. So how to find, we want to find, what do we want to find again? Sorry. Potential energy, right? Okay, we want to find what is the potential energy, delta U. When we move the charge from this point to this point. Okay. So here, potential energy kita ada dua formula, right? Satu delta U, which is equal to apa tadi? Delta V Q naught, right? Satu lagi adalah total, di mana K Q1, Q2, I12 plus and seterusnya. So ada dua saja bila kita mau cari potential energy. So now because soalan minta delta U, which is change in potential, so sini kamu sudah dapatkan delta V. Can we use that delta V? Negative 300. Okay, boleh. So kita dapatkan tadi VP is the potential at point P. So we can use this one, delta V. Okay, sorry guys, let me explain again. Okay, so kita tahu kan delta V adalah sama dengan V final minus V initial. Macam tu kan? So initially, dia adalah dekat point infinity. So dekat point infinity, V sama dengan KQ divided by R. So infinity, we don't know, dia terlalu jauh. So the distance is infinity. So if it's infinity, the V is approaching 0. So kita anggap V initial dia adalah kosong. So V initial adalah kosong dekat sini. V final minus V initial. Then darab dengan Q naught. So V initial adalah kosong. So V final kita adalah dekat point P dan kita gunakan this value. Okay, so this one negative 6,300 times with Q naught. Q naught is what is the value for the Q? Q3 ni, because we want to move this Q3. What is the value? This one. Positive 3 microcoulomb. And then you can find the delta U, the change in potential. What is the change in potential?
Negative 0.0.
Negative 0.
0.0189.
Sorry, Amin. Tak dengar lah. Negative
0.189.
0.189
At
joule.
0.0189.
0.0, okay. 189 joule. Okay, thank you Amin. Semua dapat?
Dapat, Miss.
Dapat.
Dapat, Miss.
Okay. So, next question. Okay, next question is, when the charge Q3 at point P, calculate the electric potential energy for the system of charges. Okay. So now, charge Q3 tadi tu daripada infinity kita letak dia ke point P. So now dia berada dekat point P. So kita punya whole system sekarang ada 3 charge and we want to find what is the electric potential energy, total potential energy. So gunakan the second formula untuk potential energy. We want to find U, right? Mana U adalah sama dengan K, Q1, Q2, R12. Okay. Plus K, Q2, Q3, R23 plus Q1, Q3. And then you masukkanlah the value 9 exponent 9. And then Q1 tadi adalah Q1 2 microcoulomb, Q2 negative 6. 2 microcoulomb, negative 6 microcoulomb divided by the distance between them. What is the distance? 1 and 2. What is the distance here? Should be 3 meter, right? Dekat sini.
Yes.
Okay, 3 meter. So 3 plus Q2, Q3, negative 6 exponent negative 6 times with Q3 adalah 3 exponent negative 6. Okay, sorry guys, tidak kemas pula Miss buat. And then here will be 4. And then tambah lagi, okay, Miss letak di bawah. Q1 and 3. 3 is negative 6 exponent negative 6. Oh, sorry. Negative 3 exponent negative 6 divided by the distance 1 and 3. 4. Betul kan ni? Sorry, this one 5. 2, 3. 2 and 3, 5. Okay, kalau ada salah bagi tahu ah.
Negative 0.0549.
Negative 0.0549 joule. Okay, thank you Amin. Semua dapat negative 0.049 joule. Okay. Ada soalan so far?
Dapat Miss, tak ada ni.
Dapat.
Dapat
Okay.
Miss, dapat kami.
Okay, semua dapat. Okay, so last example untuk 1.3. So this one example 23. For example ni sebenarnya soalan tutorial number 8 I think. Tapi Miss bincang lah so that nanti kamu tidak perlu buat. So this one soalan tutorial number 8. Okay, so soalan A ni Miss skip saja sebab dia senang. Okay, soalan B. So here we are given 3-point charges. Again, kita dapat 3 charge. Positive Q, negative 3Q, positive 2Q. And then what we want is calculate the electric potential energy of the system of the 3 charges. So keluarkan formula K Q1 Q2 divided by R12 plus Q2 Q3 plus Q1 Q3. Okay. But from this question, we are not given the value. Kita tidak bagi value. We are given in terms of unknown, which is Q, Q here, Q, and then A. The distance between them is A. So, buat je macam biasa, but your final answer will be in terms of unknown. Okay. First of all, let's label. Kita label dahulu, this one is Q1, this one is Q2, this one is Q3. And then the distance from here to here would be the square root of A square plus A square. Sebab pada sini A ni pun A kan. So kamu akan dapat square root of 2A square. So it will be square root of 2A. Betul kah? This one, yes. Betul? Kalau salah bagi tahu Miss ah.
Betul, Miss.
Betul. Okay, so now kita sudah ada label setiap ni. Lepas tu kita sudah ada the distance here. So kita boleh masukkan. So masukkan the value 4K. Okay, K ni nanti kita masukkan dahulu. Kita masukkan these 3 charge dahulu. So Q1 adalah positive Q. Q2 is positive 2Q divided by the distance R12 is here, square root of 2A plus Q2 dan Q3. So Q2 2Q negative 3Q divided by the distance which is A plus Q1 and Q3, this one. Q times with negative 3Q. The distance between them is A. Lepas tu, selesaikan macam biasa, you will get this one is 2Q square negative 6Q square plus negative 3Q square. Okay, and then after that it's just the maths. Okay, kamu selesaikan secara matematik saja. So now kita mau samakan the, what you call it, the, dekat bawah dia ni. Ni pun lupa apa nama dia. Denominator. So kita mau,
Denominator.
okay, kita mau samakan. So kita akan dapat 2Q square. This one, okay, selesaikan this one dulu. Negative 9Q square divided by square root of 2A. And then And then what's next? Masukkan K. Lepas tu kamu akan dapat this one. Betul kah? Sorry. -9. Dan dapat bagi dengan 9Q square dapat bagi dengan square root of 2. Macam tu kan?
Ya, Miss.
Okay. Lepas tu selesaikan macam biasa. So kita selesaikan yang ni. 2 -9 square root of 2. Kamu akan dapat -11.7 Q square. Cuba tekan, betul kah? K2 tolak -9, tolak 9 dah square root of 2. Here's my calculator.
-10.72 saya dapat, Miss.
10 kah? Macam mana Miss boleh dapat? Sekejap. How do I get this 11.7? Di mana salah? So here kita akan dapat -9Q square. Okay, let me padam dulu. Bahagi dengan A, like that. And then because we want to samakan denominator, so kena darab dengan square root of 2, right? And then bahagi dengan A. Sorry, this one. Okay, kamu dapat berapa tadi tu? 10 point?
-10.73.
10.73. Ada eksponen? Ini
Dah panjang dah
10.73.
punya duluan.
Okay. Lepas tu bahagi dengan square root of 2A. So this one ada Q square. And then selesaikan this whole thing. Dapat berapa? Negative
9.5.
9 point
6
6. 6 point
8285. Exponent 10.
exponent 10 Q square divided by A. What's the joule? Di jawapan negative 7.46 exponent 10. Mana yang silap? Let me check. What is it? Dah kami buat soalan. This one, oh my god, the 7.59 should be 7.59. Okay.
Miss tu dia tidak nilai K dia tu.
Okay, sebab dia bagi in terms of K. So should be betul lah kan? 7.59 exponent times weight dan exponent 9.
Ya, Miss. Kalau buang K-nya
betul lah.
dapat tu balik.
Okay. tiba-tiba tak yakin pula. Okay, so maksudnya you leave your answer. You can either leave your answer in terms of KQ square divided by A ataupun K tu, sebab K tu kan ada value, so kita boleh substitute lah K tu. Okay, so gambar ni, this one. This one is the final answer. So this one soalan tutorial number 8. So nanti kamu just ambil gambar yang ni je lah and then masukkan dalam soalan, hantar nanti sekali dengan tutorial 1. Okay, ada soalan?
Tiada, Miss.
Tiada. Semua lapar sudah ni. Okay, kalau tiada soalan, 1.4 kita akan sambung minggu depan on Monday. So esok kita punya slot untuk practical, untuk buat lab report. So esok kita akan buat eksperimen 1, misalkan bagi data nanti dan kamu buat lab report macam biasalah. Ikut the latest format macam yang kamu buat dalam lab report assignment. So your whole procedure tidak perlu terus masuk kepada data semua, the discussion. Okay, procedure tidak perlu, kamu terus calculate the data, buat graph, buat discussion and conclusion. Okay, sama macam yang kamu buat untuk assignment sebelum ni, lab report assignment. Okay, procedure kita tidak perlu tulis sudah sebab buang ink je tu. So buat guna pen lah, maksudnya tulis, Miss tidak mahu dokumen. Okay, so that one untuk esok. 1.4 on Monday. Okay, kalau ada Google Meet nanti Miss bagi tahu. Haristin, ada yang speaking test sudah kan? So siapa yang speaking test, kalau Miss buat Google Meet nanti inform Miss lah kalau kamu tidak dapat join. Kalau Miss tidak buat Google Meet, kamu isi saja attendance, nanti link yang sama. So hari ni tidak perlu isi attendance sebab attendance automatic daripada kamu punya siapa yang nak masuk Google Meet ni lah. Okay, so next time kalau kita ada Google Meet, kamu boleh share your device with your friends. Contohlah kamu ada kawan yang sama bilik atau dekat bilik kamu, so untuk menjimatkan data, share lah satu device. Mungkin ada seorang ni data dia banyak kan, unlimited. So kita boleh, kamu boleh share. So kalau kamu share, kamu bagi tahu Miss so that I can take note siapa yang masuk. Okay, sebabkan kamu gunakan satu device, maybe share 3 orang. Okay, tiada masalah. You just tell me kalau kamu share lah. Okay, so that nanti tiada lah yang keluar masuk. Okay, banyak sudah yang keluar masuk daripada tadi ni. So that one next time if we have Google Meet lah. Okay, so before that, before I end the class for today, ada soalan lain? Tiada?
Tiada, Miss.
Tiada, Miss.
Tiada. Yang lain?
No,
No
Miss.
question. Okay, so kalau tiada soalan, okay, nanti Miss akan pause this recording. Nanti petang ni kalau sudah ready. So Miss akan pause this recording, nanti kamu siapa yang tersekat-sekat lain dia tu boleh tengok semula lah. Okay, so I think that's all for today. Thank you. And you guys have a nice lunch.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Miss.
Thank you, Miss.
Thank you, Miss.
Miss, thank you.
Okay, you're welcome.